Hi, welcome back. Well, what you see on the bench before you is an Eico model 1020 solid state power supply. We have, of course, a voltmeter. We have a selection switch. Up is 6 volts, down is 30 volts. So you can run anything from 6 to 30 volts on here. Fuse, of course, on-off switch, and potentiometer, and banana jacks. And that's pretty much all to it. It's not a very complicated thing, but if I'm going to be working on some transistor radios, I need the lower voltage power supply. Now, you will note that I have 2 of them. Why? Well, because I can. No. I found this one on eBay for a really reasonable price. And then a few days later I found this one on eBay for another very reasonable price. So I bought them. It's kind of like woodworkers with clamps. You can never have enough power supplies. This one is also a 1020. Fuse holder here. Not the same as this one. So we're going to look into that. Voltage control and on-off switch. Now you'll notice that the 2 knobs are different. I don't know exactly which one is the original, so we're going to look into that also. Other than that, everything else is the same. So what we're going to do is we're going to test these, see if they work. So give me a moment. Okay, here we have, we're going to call this one supply B. So first thing I've noticed is this, I don't know if you can see how loose that is. This one's not too bad. So I don't know, this one's been turned many times. I don't feel much resistance inside, so this may not be connected. But we're going to see here. Alright, let's flip it to 6 volts. Hope you can see. And we'll turn it on. Okay, we show, well, minimum voltage is about 1/2 volt. I guess that's okay. Nice and smooth. Okay, that's 6 volts. So let's see what the meter says. Huh, I'm surprised. 6.23 volts, even though this is loose. Good. So we'll switch it to the 30 volt scale, which is this top one, by the way. Nice, easy, smooth. Okay, it says 30 volts. Let's see what our meter says. 3404. We're in the ballpark. I'm pleased with that. So let's disconnect this one, and we'll go to the other one. And be right back. Okay, here's power supply A. So, like I said, different knob than the other one. I'll have to check in, see which one's the original one. This one's not loose, nor this one. So let's hook up our meter. You'll notice that these binding posts have a hole in the side of them so that you can put wires or test sleeves, whatever, in them. They're pretty good quality. Okay, we're all set. So again, let's start with the 6-volt scale. Yeah, maybe it's a little bit too glary for you. Alright, let's try that. Okay, we're going to switch it on. Whoa! Well, I was reading about not quite 1.5 volts. So, not smooth. Not smooth at all. Although the regulator is doing pretty good, 6.06 volts. So we'll turn this down, go to the 30-volt scale. Not very smooth. Well, that's smoothed out a little bit. Alright, so that's 30.94 volts. Not bad. I got a suspicion that the jumping of the needle is because of this potentiometer here. You know how they get dirty from, over the years. So I'm got a feeling that that's the only difference, because in the higher voltage ranges up here, we're not getting too much jump. But when we get down to the lower ranges and switch over to 6 volt, everything's in this lower range. Look at how that thing moves. Okay, so that's that. Well, let's pull them apart and see what we got. Be right back. Alright, well, seems like we have two different beasts here. Power supply B, it's got 2 transistors, 3 electrolytics, 1 electrolytic here, and 2 diodes. Plus, let me get a pointer here. Plus, if you can see down inside here, there's a dual pot and a switch here. Okay? That's this one. Now, power supply A, transistors are gone, but somebody put in an LM317, which is the reason that it only went down to 1.5 volts. That's the minimum voltage for that. But we have 1, 2, 3 electrolytics. The 2 diodes are gone. Somebody put in a full wave bridge rectifier. And if you can see, a single pot and the switch. Very interesting. If I had to guess, I'd say power supply B here is probably the original. Now, I have no idea if these were kits. I don't even know if they offer this in a kit. My feeling is that when these things left the factory, they were already built. And the reason I say that is, I really hope you can see it, we have a rivet here, a rivet here, a rivet here. Okay, here's the other side of the rivets. One here, one here. On this one, rivet, rivet, rivet. And here's the other side. Rivet, rivet, and no rivet. Oh, it's behind the voltage regulator. Plus, there's a screw here which the voltage regulator was bolted to. So this one's been worked on. The other one I think is pretty straight. Now, here's the weird part. I downloaded the manual for it. I don't know if you can see that, but we'll go over it later. It's an Eico 1020 solid state power and bias supply. Now if you look on this picture here, you'll notice that there is a logo right here of Eico, which means this is probably a newer one. There's no logo on this one. There's no logo on this one. And we look at the schematic. I'll get it for you here. Okay, we have might help if I turn it right side up, huh? Okay, we have one transistor here, Q1. I don't see any other transistors in here. Here's the two diodes. Plus, I see one variable pot here, but not at the second one for dual pot. It shows this going over to the switch. That's understandable. So I don't think this schematic is right for either one of these. I'm going to have to do some more investigating. So what are we going to do? Well, since this one's working, power supply B is working, I don't think I'm going to mess with it except maybe change the electrolytics. Although I don't see any bulges in them. Maybe we'll put this one on the scope and see how much ripple we have. This one these capacitors have been changed. I don't know about this resistor. I don't see it on the other one. Somebody probably put it in there for the LM317. And the bridge rectifier, that's okay. This one is a little bit more modernized. But I don't know. We'll have to look into this one. So what we're going to do next is we know that this power supply works. We just don't know how old the caps are. Oh, by the way, I don't know if you can see in here. Let's see here. This is that banana plug that was loose, But you'll see it's still attached. There's a lug. So we'll just need to tighten this up a little bit, and that should be good to go. Both cases are good. This B has the original power cord on it. You'll see it's the gray. Power supply A has a different power cord on it, black. Plus this one, power cord's cracked, so it's probably a little bit old. I'll tell you, the solder joints are not that good on here. It's not like I would expect from a factory. Big blob of solder here. This one isn't soldered very well, nor is that one. So next time we come back, we'll see about changing these capacitors here. I got to do a little bit more searching, see if I can find the right schematic. This one here has some sort of a tag inside in here that the other one doesn't have. It says 1020 31010 0153. Obviously that's the model number. I don't know if this is a lot number, date number. This could be a date code, 1973, which would sound about right. Don't know, maybe this is the series or something. I don't know, we'll have to do a little bit more investigating. So with these two power supplies, I should be able to work on those transistor radios and other things. The output on them is only 500 milliamps. It doesn't say there. I know I saw it somewhere. Says the maximum ripple under any load current is 300 milliamps. Now this says a power transistor is a TO3 case and a rugged power transformer are used. Looks like it's got a max of 300 milliamps. Oh, here's the specs down here. Maximum current 300 milliamps. Ripple with a full load is 1/200th of 1%. 120 hertz. 1/200th of 1%. That's pretty good. Power consumption is 21. Oh yeah, here we go. Copyright 1973. So that is a date code on there. All right. We'll bring you back when we got something else to show you. Well, we're going to see what we can do with this. This is the one that has the wonky volume controller pot. I'm going to see if I can put some deoxit in there and see if we can clean it up. So let's see here. Put a couple drops in there. I did take the knob off of here. You can see this is not the original pot, but the shaft has been cut off. Okay, I finally got the knob put back on. So let's move this a little bit. Okay, let's plug her in and see if it works. Okay, we're all plugged in. Let's see if this thing works. I'm looking at. That's the 6-volt scale. Let's try the 30. Well, it works, but I think there's something wrong with that meter. I'll show you why in a minute. Let's try the 6-volt scale again. Well, that's showing 6 volts. Not much. I don't like the way that thing's bouncing around. Well, let me put a little bit more deoxit in it, and then we'll take another look at it. I'll be right back. Okay, I put some more contact cleaner in there. Let's try it. I did move it around a bit. I don't know if you can see that well. Ah, that's better. Okay, we're on 30 volts now. Well, that seems not too bad. Still bouncing around a little bit more than I'd like. Okay, let's try the 6-volt scale. Proof is in the pudding here. I don't know. The control isn't moved very far for 6 volts. It should be a farther travel than that. Let me hook up the voltmeter and we'll see what happens. Okay, we've got the voltmeter hooked up on it. Turn that on. Hope you can see it. Alright. Let's try it on the 30-volt scale. Goes down to 1.81, which is about right for a LM317. Now it's not jumping around on the multimeter. So that's 32 volts. And maxed out it goes to 33.6. Alright, let's shut this down. Let's go over to the 6-volt scale. 1.26, that's about right. Whoa. Very, very touchy. Yeah, 6.93. It's not too bad. Full on it goes to 16.4, but then the needle's pinned way before that. Don't know. Well, you know, when somebody's modified something, you just never know what's going on. So we're going to have to do some more investigating into this. Might have to replace that meter. I'll show you why I'm thinking that. Let me get these off of here. Okay, here are 2 meters side by side. I tighten this binding post up, so we don't have to worry about that. Now this is what I mean. When I tap this, it makes a liar out of me. But look at this one. This one's moving a little bit. A lot less than it was. I don't know what. I certainly didn't do anything to the meter. But look at this one. So, I don't know, I'm going to have to investigate it, but not now. I got those couple of those transistor radios I want to work on. So we're going to use this one here. I still have to see if there's any sorry about that, the mind went blank. I still have to see if there's any variations in the voltage. I don't know if I can get my my scope hooked up to it or not. We'll see. So with that, thanks a lot for watching. I appreciate it. Please like, comment, subscribe, share. All is appreciated. With that, we'll see you next time. Bye.